Good morning. In this video, we are going to continue with chapter 11 construction. We had already seen how to divide a line segment in the given ratio and how to draw the tangent to a circle from an external point when the distance of the external point from the center is given and the angle made by the tangents at the external point is also given. So now let us move on to the last type of construction. The question number 6 from exercise 11.2. Let ABC be a right angle triangle in which AB is 6 centimeter, BC is 8 centimeter, and angle B is 90 degree. BD is the perpendicular from B on AC. The circle through BCD is drawn. Construct the tangent from A to this circle. So for this, one thing we have to revise through the concept is that if you're having a diameter, suppose a circle with center O and BC is the diameter which is passing through O also, then any triangle formed in a semicircle will be 90 degree. Okay, so this is an idea which we need for this construction. Now let us move on to the construction. So over here, first it was given that BC is 8 centimeter and angle B is 90 degree. So first of all, let us construct 8 centimeter. So this is BC for us. Now at B, we have to construct 90 degree. You already know how to construct 90 degree, don't you? So let's take the compass. Take a suitable radius arc. We are going to cut the arc and from this point we'll make the arc again from the previous arc. We're going to cut it to make 120 degree with the same radius about let's draw an arc and again from the 120, isn't it? So let us cut the previous arc. Now if you're going to join these two, it's going to be 90 degrees, isn't it? You are well aware of 90 degree construction, and I think you must have completed it by now. Okay, so this is 90 degree for us. Now okay, so we got 90 degree. Now we have to make 6 centimeter. AB 6 centimeter. So again, let us take the scale, mark 6 centimeter and cut the arc from B. Okay, so from B, we are going to cut the arc, which is A. We need to extend that previous 90 degree. Okay, Okay, so this point is A for us. Okay. All right. Now let us join A and C. Okay. Now we have to draw D, isn't it? Perpendicular from B. It's given perpendicular, not perpendicular bisector. So how will you draw perpendicular from B to the side? Now from B, what we are going to do is draw an arc. Okay, so if you're taking like this, we'll draw an arc in such a way that it will cut AC. Okay, take a little bit smaller. I don't want very big one. Okay, I think this will do for me. So this way, I'm going to cut the arc. With the same radius itself, we can cut the previous one. Just make an arc, same radius from this part. Okay, I'm going to make an arc over here also. So actually when I do that, I'm not able to show it to you. So I will do it on this side. Either ways, I'm going to get the same. Okay, so we have to cut the arc over here. Okay, so when we do that, we'll get it there. And when we join those two, we will get D. Okay. Okay. So this is the point D for us. Okay. So the arc for me actually has gone outside the area, but when we cut it, we can join B and the arc where it's cutting and we'll get D. Now I told you D is perpendicular, isn't it? And at the beginning of the question, I told you that in a semicircle, it's always perpendicular. So if you are considering this a semicircle, that means BC is the diameter. Now to get the radius, we have to draw the perpendicular bisector. So let us draw the perpendicular bisector for BC now. So we have B and C will take more than half, isn't it? So let us do that. We'll take more than half. Let's make an arc above and an arc below. Again, from C, we are going to cut an arc above to cut the previous one and an arc below. Now let us join these two. When you're this particular construction has a lot of uh, bisectors cuttings, so if you want you can make this in a dotted line. Okay, because all we need to know is the center. Okay, center of the circle, that's all we need to know. So you can make this a dotted line for convenience. Okay, now we got the center, which is, let us take to be O. Okay, now let us draw the circle. This is actually the original circle which usually is given to you, circle of radius 5 centimeter. All that is usually given, isn't it? Here even that is not given. So now we are going to draw the circle. Okay, now see, this circle is passing through D, B and C, which was given in the question. Now if this much is right, then your construction so far is perfect. Okay, now this is actually the circle that we need, and from point A we are supposed to draw tangents. That's all. Okay, so now A is the external point and the circle with center O is our original circle. So like the first way how we drew the tangent, we are going to draw the tangents. Now for that, first let us join the external point to the center. Okay, So from A, join A and O. Okay. Now we have to draw a perpendicular bisector for this, isn't it? So let us draw that. How will we draw? Take more than half of AO. AO is the one for us right now. So I'm just change the color so that it won't be very confusing for you. I understand this construction is a little bit complicated. Okay, and you will complicate it in the sense you will have lots of arcs on. Okay, now same way with the A, we are going to cut the previous one. Over here and here. Okay, now let us join them. Very big arc because my is not very big. I have a small screen over here. That is the reason that I need to do it this way. So let us join these two. And this is the perpendicular bisector. Okay, now this will be M for us. Usually we have the middle point, isn't it? So we'll take that to be M. Now the usual way how we are going to draw the circle. So let M as center and OM or AM, whichever as center, the radius, we are going to draw the circle. Here OA, they're all cutting through, so it is perfect. Now let us join wherever they are cutting. See AB, it will cut at AB. AB is actually one of the tangent for us. We have to join the other point only over here. Okay. So A with the other point we are going to join. Okay. The point where it cuts. All right. So now AB is one of the tangent. We have CD. So you can give any name. I'm going to take this to be AE. So AE and AB are the required tangents for us. Okay. So how were we doing? First we drew the, we constructed the triangle and then we constructed the point D, which is the perpendicular. And then we know that in a semicircle it is 90 degree. So we did a perpendicular bisector to find the center so that we can draw the circle, which is the required circle, the given circle usually for us. And then A is the external point. So from the outside point, we are going to draw two tangents. So when we draw perpendicular bisector and then draw the circle with the bisector to be the midpoint or to be the center, and then we draw the circle joining them, we get AB and AE to be our tangent. So this is the end of the chapter. The steps of construction is given in the notes. You can go through it. So these are the types of questions that can be asked from this chapter. So we have come to the end of this exercise as well as the chapter. The questions not solved in the class will be homework for you all. Thank you.